When we open up the plugin, this is what comes up. And if you've used the hardware that this is based on, it will probably look familiar. But if not, it also looks pretty simple and inviting to just dive right in. Minimal controls makes it pretty quick to set up. The first control here is an input trim into the compressor, with plus minus 12 dB of gain. Then this big red knob is the threshold. It uses a pseudo RMS design, but the threshold is compensated to more closely follow the peak levels. And as the signal starts to exceed the threshold, we see the gain reduction meter shows us the compression being applied. And the meter is tapped directly from the sort of true RMS detector, just like the hardware. This 3 LED meter shows where the detector is relative to the threshold level. Red is above, green is below, and if we set this soft knee, which changes dynamically based on the signal and ratio settings, the amber light in the middle tells us when the signal is in the knee zone. The big blue knob is the compression ratio setting, and it starts out pretty normal, and then goes into a limiter, and then beyond that into these negative ratios, which can make some nice effects for reverb tails on percussive elements, for example. Negative ratios are more extreme than a limiter. Where a limiter sets the overshoot level to the threshold level, negative ratios start to move it below the threshold, directly related to how far the overshoot is over the threshold. So at a negative 1-to-1 ratio, a signal 6 dB over the threshold will be attenuated to 6 dB under the threshold. So the louder the sound is over the threshold, the quieter it becomes at the output of the VCA. And the big green knob is a makeup or output gain. Then this big yellow knob is the mix control, and the dry signal is the input signal, not affected by the input trim or output gain. Above that, we have a button for oversampling that we can turn on and off. When enabled, the oversampled components run at a fixed ×4 rate, which seemed the best trade-off for aliasing reduction, CPU use, and low latency performance. Then below, we have a harmonics control that goes from 0 to 400%, with 100% being the harmonics level from the nonlinear output on the unit that was measured. And next to that is a transformer button, which simulates the transformer that was an optional mod on these units, but toggled at the click of a button. So now let's look at RLC-79 in Plugin Doctor. Flat frequency response, unless we engage the transformer. Then we see some slight changes. Same with the phased response. Now with oversampling enabled, we see some phase disturbance in the upper spectrum, which is due to the polyphase design, which has some phase shifting and subsample latency, but seem to maintain a more naturally defined high end and offer superior low latency performance compared to the linear phase methods that were looked at. When I addressed this oversampling method's design flaws in the QX comp video, I noted that a major drawback was the lack of ability for parallel signals. With the dry-wet design on this, the dry signal is also polyphase oversampled to line up with the phase and subsample latency of the compressed signal perfectly. Now let's look at the harmonics analysis. We see the harmonics control adds an interesting harmonic series, and if we adjust the threshold, we see it behaves dynamically with the compression behavior around the threshold. And these harmonics appropriately change in volume as we use the control here. We see a small difference with the transformer enabled. This particular transformer has a fairly good linear output transfer curve. Now, if we try to really generate some aliasing, now we see kind of a good response here between the peak and kind of the worst of these aliasing spikes here. But when we enable the oversampling, we see we get an even better result. Now don't get this confused with its predecessor, which has been modeled by several big brands already. While it offers the same type of program-dependent snap, it is slightly different sounding in its attack and release behavior. The attack is sharper, and the release is also slightly different with a less transparent tail, which actually can add quite a nice difference compared to the original, for instance on fast, clicky, more metal-sounding kick drums. Let's check that out. We'll set the threshold and ratio. Sounds good at about minus 6 dB or so of gain reduction. Now a little makeup gain. Maybe just a tiny bit of the dry signal blended back in. Dial in the harmonics. And now engage the transformer. And oversampling. Pretty quick. Here's before and after. Now the transformer simulation is after the mix control, so even if we set it all the way to the dry, the transformer still makes a subtle difference. RLC-79 works similarly well on tom groups, maybe a slight negative ratio to bring out the room, set the threshold, makeup gain, blend in the dry, adjust the harmonics, try out the transformer, enable oversampling, before, and after. The softney of the RLC-79 can also tame the boominess of a bass guitar much differently than its predecessor. Turn the softney on, set the threshold, ratio, output gain, parallel. Nah, I think this sounds better with the 100% wet signal. Harmonics, try the transformer, enable oversampling, and here's the before and after. And I found that if I'm going to use this on both kick and bass, it feels more separated between the elements if I use the transformer simulation on just one of those elements and leave it off on the other. I hope that gives you a pretty thorough understanding of RLC-79 and how to use it in your audio productions. RLC-79 is now available for download at the link below.